So that is an example of a system of linear equations. In your notes, you've got a few things that you need to fill in as you're going along. So I will open up those boxes so that you can see them. And I already talked about this idea that system means that you have two or more of something. And both of these are lines. So if I just gave you x plus y equals 5, it could be 1 and 4, 2 and 3, 0 and 5. There's lots of possibilities if I just give you one equation. But if I give you a second equation, and I say x plus y equals 5, I'll also tell you that x minus y is equal to 1. Let's use some guessing and checking. Can you figure out what x and what y would make both of those work? Can you guess and check and figure out an x and y that would make both of those work?
3 and 2.
So if x is 3 and y is 2, does it work? Does 3 plus 2 equal 5? Yes. Does 3 minus 2 equal 1? Yes. Didn't take us too long to guess and check because the numbers were fairly nice. So the system that we are going to look at is two equations and two variables. Maybe I think it's next semester. You can draw a line in 3 dimensions, right? Like if I just took a straight line, like a ruler, and held it here, it would be a straight line. And we're living in 3 dimensions. 2 dimensions work is what you do on a piece of paper. It's where we start our math. But a lot of real life math involves 3 dimensions. And you could have a line in 3 dimensions, and then you could have another line in 3 dimensions, and those two lines could cross. This becomes very important with airplanes flying, because you don't want them to cross. Or at least you don't want them to cross at the same time. They can cross the same point like an hour later as a controller at the airport. You'd be like, I'm okay with that. But if they cross at the same time, really bad things happen. Right? Bad things happen to the people that are in the planes, and then the person who's in charge of it on the ground, the bad things happen to that person too, because they were supposed to not have that happen, that the two planes cross at the same time. That will be a system we'll have later with 3 equations and 3 variables. But this idea, we start by having 2 lines on a paper and finding out where they intersect. So we call the solution of that 2 by 2 as the coordinates that satisfy both equations. And the one that we did here where we guessed and checked, yeah, if x is 3 and y is 2, that is the only way that both of those can be solved. And graphically, this represents where both of these graphs intersect. So if I wanted to do this graphically using my last unit, I could say, well, I could get my y by itself. This is really nice, because this would tell me I have a y-intercept of 5 and a slope of -1, down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. Or I could have used the intercepts method and found my x-intercept and my y-intercept, and I could have drawn that graph. Similarly, I could get y by itself on the other graph. if I was getting y by itself on the other graph, I would probably think about moving my y to this side and my 1 to that side. And you see that that would give you x minus 1. Okay? If I have x minus 1, well, that means I'd have a y-intercept of minus 1. And now I have a slope of positive 1, up 1, over 1, up 1, over 1, up 1, over 1. And there, on my graph, I see that those two graphs intersected at 3, 2. Part of the problem with drawing it by hand and not using graph paper is that your scale might be a little bit off and hard to see exactly where they cross. But if you had graph paper and did it very accurately, then you could find out where they cross easily. So this system we already figured out had a solution of 3 and 2, and we would write that as the coordinates. 3, 2 is the solution. And if we verify it, both equations work. And we are going to learn different ways to solve these. And there's something about solving something, I don't know, I find it very satisfying. Okay? So, guess and check, graph, whatever you want to do. See if you can figure out numbers that make these work. Do some mental math. You have to find an x and a y that make both of them work. I think the second one's harder than the first one. So there are the solutions for those ones that you tried on your own. And method 1 is connected to our last unit. We can solve things graphically. So the solution we already talked about is the place where they intersect. So if we can graph accurately, then we can find a solution by seeing where they intersect. So we have to use our skills from our previous unit. How can you graph? So here's a little graphing review. Okay? I think this will be a favorite way to use it, so I'll list it first. If you change your equation to y equals mx plus b, then you'll know your y-intercept and you'll know your slope. If you know both of those things, then you can easily find a whole bunch of points and draw your line. I think that'll be a favorite method for most of you for graphing. Okay? 2, you can always graph with a table of values. Plug in any value of x and figure out what y. You can find a bunch of x's and y's, so a reminder, this is where you plug in any value of x and get a value of y. Similar to the table of values, you can graph just by finding your x-intercept and y-intercept. Those are two specific points. Then if you took out, and this would be a place where I'd say, especially for finding out where they intersect, we want to be accurate. So I would say take out a ruler and then draw your line nice and straight. Because if you draw your line crooked, it's going to intersect possibly at a wrong point. But I think the favorite method will be the y equals mx plus b method. But sometimes you might not like the y equals mx plus b method, and you might want to try one of those other methods as well. So, I'm going to color code this. I'm going to make this one in blue, and I'm going to get the y by itself by moving x over. And I'm going to do this one in green, and I'm going to get the y by itself by moving the y to this side and the 8 to this side. Can you do that all at once in mental math? And you see that if I move the y to this side, it would be all by itself. And I'll write it, it'd be all by itself on the right side. But can you see with an equation, it really doesn't matter if things are equal, what's on the right side, what's on the left side? I'm going to write y equals, and if I move the 8 to this side, I would have 2x minus 8. So, my blue graph has a y-intercept at 1, 2, 3, 4. It has a slope of -1. Negative slopes go down from left to right. So I go over 1, down 1, over 1, down 1. Now technically, this is enough points to draw a straight line, right? But I could just keep going and draw a whole bunch of points. Now this is where if I had a ruler, I drew a lot of points so that I could sort of get away with not having the ruler. That is my line, but a ruler would have been nicer to make it really straight. For the green graph, 2x minus 8. And the slope of 2 is positive, so it's going to be going up from left to right. I'm going to go up 2 over 1. Up 2 over 1. Okay? And if I kept doing this, up 2 over 1, up 2 over 1, you see that the two, my dots even intersected already? And there's my key point. What are the coordinates of that point? My x coordinate is 4. My y coordinate is 0. So I'm going to say that I think the solution to this equation, is 4, 0. Let's double check it. Is 4 plus 0 equal to 4? Is 2 times 4 minus 0 equal to 8? Yes. Now you have to decide at this moment, in this question, what do you think would have been faster for you? Guessing and checking, or drawing both graphs? Some people might say, I think I could have got it quicker guessing and checking. Some people might say, I wasn't very good at guessing and checking. Maybe the graphing way is faster for me. Sometimes what we do in real life is we start by guessing and checking because we think it would be faster, and then we can't find an answer, and then we're like, oh, I guess I'll have to try another method. Oh, here I just have a graph. I guess I took out the equation. Let's see if I've got it. There's it. Okay. Again, we want to graph this. I'm going to start by changing to y equals mx plus b. I'm going to do, again, this one in blue and this one in green. Color coding is nice because then after you've done your work, when you look at your graph, you're kind of reminded, oh yeah, all of my blue work goes with my blue graph, all of my green work goes with my green graph. It can kind of help you study when you look at it later. So with the blue one, can you see that you could move the y over to get it by itself, move the 10 over? 2x minus 10, which would give me a y-intercept, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, at minus 10. And a slope of 2, up 2 over 1, up 2. Positive slope, so we're going to go up from left to right. I mean, I did all the dots. I kept going with my slope because I'm hoping that one of those dots is my solution. The green one, if I want to get the y by itself on the green one, I'm going to put, that's the term with the y. So I could get that minus 3y by itself by moving the 2x over. Make sure you're following along. Does that make sense what I did? How I got the minus 3y by itself. The minus sign stays with the 3. Sometimes we have to be careful with that. Okay. Now, if I wanted to get y by itself, I would have to divide by a negative 3. Negative 2 divided by negative 3 is positive 2/3. And 14 divided by negative 3 is going to be negative 14 over 3. This is a great example of where I actually don't like my y equals mx plus b method. Why don't I like my y equals mx plus b method for graphing? Anybody know why I'm not very happy right now? M is a fraction. Blech. Just a little bit of a blah, right? Would you like to, like, when we graph y equals mx plus b, we usually start with the b value. Where are you going to put negative 14 over 3? Like, you could estimate it, but isn't it a bit blah? I don't know if that's a proper math term or not, but maybe a little bit. It's like, ugh. Okay. So I don't like my y equals mx plus b. What else could I do? I could do a table of values. I'm going to add a fourth one on here. Maybe you want to go back and add this as well. We could also graph, if we had the slope and any point, and in brackets I put, I'd like a nice point. Because we had, in this one, because y equals mx plus b is a slope and a specific point, your y-intercept. But I would much rather have a nicer point with my slope rather than my ugly point, which was my slope-intercept. So let's go back here. I could also graph this with a table of values. I'm going to ask you to do a bunch of mental math until someone finds a nice point for this graph. Can anybody figure out a nice point on this graph where both the x and the y are integers, nice whole numbers? But before we find out one that's not nice, give me a random x value. 3. So we're going to check if 3 gives us a nice point. If I plug in 3 for x, that would be 2 times 3 minus 3 times y equals, right? This is how we do our table of values. You pick an x value, you plug it in, and then you solve. So then I would get minus 3y equals, if I move the 6 over 8, Oh my goodness, you did not find a nice point. I have to add the word, mathematical word, blah. Okay. So we could just keep randomly checking. We checked 3. We could just keep randomly checking, or someone might find one. What should I try next? Let's try 1. So if we try 1, it would be 2 times 1 minus 3y equals 14. So if I move this over, minus 3y would equal 12. Oh my goodness. We have a nice point. 1 and negative 4. And I'm going, so what we're doing now for graphing, I didn't like y equals mx plus b. So I looked at some of my other graphing techniques. The intercepts method is not going to be nice because I already knew my y-intercept wasn't a nice point. So then I went to table of values. And in my table of values, I went until I found a nice point, and I'm actually going to use that nice point and my slope. So let's see how that would work. So I know that I have the nice point 1 and negative 4. There it is in green. There's my point 1 and negative 4. My y equals mx plus b is still helpful because I know my slope is 2 over 3. That's a positive slope, so it's going up in this direction, which means I could go up 2 and over 3. Oh my goodness. You see we already up 2 over 3, up 2 over 3. Could go down 2 and back 3, down 2 and back 3. Those would be all the points. Now if I connect my blue points, and I connect my green points, wow, that is a terrible big red point. It sure looks like they intersect at 4 and negative 2. I'm going to say that I think the solution is 4 and negative 2. Does that work? Is 2 times 4 minus a negative 2, 10? Check the first blue equation's original equation by plugging it in. Check the green equation. Is 2 times 4 minus 3 times a negative 2 equal to 14? And this is, I think, an exciting part for me about this unit. One of the things I always loved in math is when I got an answer and I could check it. I could check my blue equation and it works. And I could check my green equation and it works. This is a wonderful thing about math when it works. It is the worst thing in math. Have you ever checked your answer? You think you've done all the work right? You go and check your answer and it doesn't work? That's like the worst feeling on a test. You're like, I thought I did everything right and I just checked it and it's wrong. You know what's the worst thing ever? Is when you do everything right, you get the right answer, and then you make a mental math mistake when you're checking, and you think your right answer is wrong. And then you spend the next 5 minutes trying to change your answer, and nothing's working, because your answer was actually right, and it was your check that was wrong. That is the absolute worst thing to happen. Check that you put arrowheads on the end of your graph because those lines continue on forever. But this is our solution. Okay? What happened in this equation? Y equals mx plus b worked great for the blue one, but it was a little bit problematic for the green one. But we did a table of values and we found a nice point, and then we used the nice point and we still used the slope from y equals mx plus b because that was helpful to go up 2 over 3, up 2 over 3 and find a bunch of other nice points. Because if you have a slope and one nice point, you can use that slope to find a whole bunch of other nice points. So these questions aren't always nice. They don't always intersect at nice points. Could I draw two lines that intersected somewhere in the middle? Yes. That's going to add another level of complexity. Right? So this is what mathematicians sort of do. They sort of start off with an easy idea like, I bought coffees for my friends. How many did I buy? And there have to be nice numbers. But then a mathematician says, well, does it have to be nice numbers? What happens if they're not nice numbers? Then you're like, oh. And then they have to develop strategies to figure that out. So this isn't the only strategy that we're going to use. The graphing strategy works when there are nice numbers. Okay, I want you to try this one on your own. There is still 15 minutes left in class. But I will close my door and you can do whatever you like. If you want to finish up that next one, you can. Oh.